Hello everyone, I am Dr. M.A. Sabita, working as Assistant Professor in Department of Chemistry, Sadakatullappa College, Tirunelveli, Tamil Nadu. In this e-content, I am going to discuss about the concepts of acids and bases. The first concept is Arrhenius concept. Acid is any hydrogen containing compound which gives H plus ions in aqueous solution, and a base is a substance which gives OH minus ions in aqueous solution. Consider this equation. HCl, which is an acid, undergoes equilibrium dissociation to give H plus and Cl minus ions. Similarly, sodium hydroxide, which is a base, undergoes dissociation to give Na plus and OH minus ions. Limitations of Arrhenius concept. Hydrochloric acid is recorded as an acid only when it is dissolved in water and not in some other solvent. It cannot account for the acidic and basic character of materials in non-aqueous solvents. For example, ammonium nitrate in liquid ammonia acts as an acid although it does not give H plus ions, while ammonia, which does not have OH minus ions, shows basic character. The second concept is Bronsted-Lowry concept. An acid is a substance which can release a proton to any other substance, whereas a base is a substance which can accept a proton from any other substance. An acid is a proton donor and a base is a proton acceptor. Example, HCl reacts with water to give H3O plus hydronium ion and Cl minus ion. Ammonia, which is a base, reacts with water to give NH4 plus ammonium ion and OH minus. Examples of Bronsted-Lowry acids and bases. Bronsted-Lowry acids and bases may be molecular, cationic, and anionic species. Examples of such species are tabulated. The types of species: acids, bases. Under molecules, HCl, HBr, HClO4, HNO3, H2SO4, and H3PO4 acts as Bronsted-Lowry acids. Ammonia, N2H4, amines, NH2OH acts as Lowry bases. In cations, NH4 plus FeH2O6 times 3 plus AlH2O6 times 3 plus H3O plus acts as acid, whereas FeH2O5 times OH2 plus AlH2O5 times OH2 plus acts as bases. Under anionic category, HCO3 minus and HSO4 minus acts as acids. Similarly, Cl minus, OH minus, CO3 2 minus, SO4 2 minus, and H minus act as bases. Limitations of Bronsted-Lowry concept. This concept cannot explain the reaction between acidic oxides like CO2, SO2, SO3, etc. and the basic oxides like barium oxide, calcium oxide, etc., which take place even in the absence of the solvent. Example, oxide reacting with sulfur trioxide to produce calcium sulfate. Obviously, there is no proton transfer involved in the above reaction. Substances like BF3, AlCl3, etc. do not have any hydrogen and hence cannot give a proton but are known to behave as acids. A given substance may behave as an acid in one solvent and may behave as a base in some other solvent. For example, acetic acid behaves as an acid in liquid ammonia and as a base in sulfuric acid solvent, as it is evident from the following equation. Acetic acid reacts with ammonia solvent producing ammonium ions and acetate. Here acetic acid acts as an acid, ammonia as a base, and an ammonium ion as an acid and acetate as a base. Similarly, sulfuric acid, which is a solvent, reacts with the base acetic acid to produce the acid CH3COOH2+ and HSO4- base. The dual behavior of acetic acid cannot be explained by Bronsted-Lowry concept. The third concept is Lewis concept. An acid is a molecule or ion which can accept an electron pair from some other substance, and a base is a molecule or ion which can donate an electron pair to some other substance. In other words, Lewis acid is an electron pair acceptor and a Lewis base is an electron pair donor. An example is boron trifluoride reacting with ammonia, where the nitrogen has lone pair of electrons. So the nitrogen donates its lone pair of electrons to BF3 to form an adduct. Here BF3 acts as a Lewis acid and ammonia acts as a Lewis base. Examples of Lewis acids: simple cations which have low-lying empty orbitals. For example, Ag plus ammonia giving rise to AgNH3+. Here Ag plus acts as a Lewis acid and ammonia as the Lewis base. Another example is H plus acting as Lewis acid and ammonia as a Lewis base. Next example is electron deficient molecule. The central atom has empty p orbitals. An example will be BF3 reacting with ammonia to produce an adduct. Here BF3 acts as a Lewis acid and ammonia as a Lewis base. The molecules in which the central atom has vacant orbitals. Example is silicon tetrafluoride reacting with fluoride ions to produce silicon hexafluoride. Here SiF4 acts as the Lewis acid and fluoride ion as the Lewis base. Molecules whose central atom is linked with more electronegative atom by double bonds. CO2 acts as a Lewis acid and OH- as the Lewis base, producing an adduct. Elements with an electron sector. SO3 2-, which is a Lewis acid, reacts with O with a lone pair of electron acting as a Lewis base, producing an adduct. Examples of Lewis bases: neutral molecules like NH3 or NH2 or OH, H2O, in which one of the atoms has got at least one lone pair of electrons. All negative ions like F-, Cl-, OH-, Cn-, etc. Limitations of Lewis concept. The Lewis concept is too general and includes all reactants which can form coordinate bonds. Even metals in their zero oxidation state are termed Lewis acid in their complexes with pi acceptor ligands such as CO and olefins. The relative strength of acids and bases cannot be explained on the basis of Lewis concept. Thank you.